Let's quickly revise ICSE 10 Standard Chemistry Chapter 2, Chemical Bonding. A chemical bond is a force that holds two or more atoms together in a stable molecule. And the reason why atoms combine with each other is to achieve the stable electronic configuration of the nearest noble gas. You see, noble gases have a complete outermost shell, that is an octet. Helium has a duplet. So atoms of other elements can lose, gain, or share electrons to complete their outermost shell and become stable. This leads to the formation of two kinds of bonds, ionic bond and covalent bond. Ionic bond is formed between a metal and a non-metal with high electronegativity difference. Metals lose electrons and non-metals gain electrons. Ions are charged atoms. Ions have a complete outermost shell, whereas atoms may or may not have a complete outermost shell. Ions can exist independently in solutions. Atoms may or may not exist independently. Now let's study an example of an ionic compound, magnesium chloride. Magnesium is a metal with electronic configuration 2,8,2. So it can lose 2 electrons to achieve the electronic configuration of the nearest noble gas, which is neon. On the other hand, chlorine is a nonmetal with electronic configuration 2,8,7, and it can gain 1 electron to achieve the electronic configuration of the nearest noble gas, which is argon. When magnesium loses 2 electrons, it forms a cation, and this loss of electron is called oxidation. When chlorine atoms gain 1 electron each, they form chloride anions, and this process of gaining electrons is called reduction. So this entire process is a redox reaction. The cross and dot structure can be written like this. The cross and dots represent electrons. We see that they have developed opposite charges, and opposite charges attract each other, and the electrostatic force of attraction between them is the cause for the ionic bond in magnesium chloride molecule. Now let's study covalent compounds. Covalent bond is formed between two nonmetals whose electronegativity difference is not sufficient for transfer of electrons. For example, let's look at the 2 nitrogen atoms here with electronic configuration 2,5. Each of them would like to gain 3 electrons to become stable, which they could get from some metal like aluminium. But here, the possibility is only for the nitrogen atoms to share electrons, because neither is willing to give electrons. Because sharing is covalent bonding. As you can see here, 3 pairs of electrons are being shared, so this is a triple bond between nitrogen atoms forming a nitrogen molecule, and that's how they attain stability. The pair of electrons which don't participate in the bond formation are called lone pairs. Now these shared pair of electrons are equally shared between them. This molecule is symmetrical because both the atoms have the same electronegativity. So there is no charge separation. Such a bond is called a non-polar covalent bond. But in the example of water, where 2 hydrogen atoms share electrons with oxygen, each hydrogen sharing 1 pair of electron, the shared electrons are unequally distributed. They are closer to oxygen compared to hydrogen because oxygen is more electronegative than hydrogen. So there is a charge separation. The molecule is asymmetrical, and such a molecule is called a polar covalent bond. And such a compound is called a polar covalent compound. So you see, oxygen has completed its octet and hydrogen has completed its duplet because of sharing of electrons. Now water is a universal solvent. It has a high dielectric constant. So whenever an acid is dissolved in it, an acid like HCl, water will break the covalent bond between H and Cl and generate hydrogen ions. And that is true for all acids. These hydrogen ions are nothing but protons, are attracted towards these lone pairs of electrons, and that leads to the formation of a coordinate bond. That's a special type of covalent bond because a pair of electrons are being shared, but both the electrons are being donated by oxygen, that is by one atom, and there is no contribution from the other atom, which is hydrogen. This does not affect the octet of oxygen or the duplet of hydrogen. It does not affect the molecule of water. It's just an additional proton attached to it, forming the dative or co-ionic bond. Now since hydrogen was positive, now this entire ion is positive. This is H3O plus or Hydronium Ion, which is the identity of any acid solution. Let's take another example of ammonia. Ammonia is a combination of 3 hydrogen atoms with 1 nitrogen atom. We have 3 single covalent bonds where each hydrogen atom shares a pair of electrons with nitrogen so that they become stable. There is 1 lone pair of electron. Now when ammonia gas is dissolved in water, the bonds of ammonia are not broken. Instead, the bonds of water are broken. So water splits into H plus and OH minus. Now this H plus gets attached to the lone pair of nitrogen to form a coordinate bond. And the positive charge is transferred to this entire complex, and this is NH4 plus or ammonium ion. And the hydroxyl ion also stays in the solution. A few compounds show all 3 types of bonds, that is ionic, coordinate and covalent. For example, ammonium chloride. Now let's study the differences between ionic compounds and covalent compounds. First, the state. Ionic compounds are crystalline solids because of the strong electrostatic force of attraction between the ions. Covalent compounds are soft solids, liquids or gases because the intermolecular force of attraction in covalent compounds, which is called van der Waals forces, are quite weak. Second, volatility. Ionic compounds are non-volatile, they don't evaporate very easily, whereas covalent compounds are comparatively more volatile. Third, melting and boiling point. Because of the strong electrostatic force of attraction between the ions of ionic compounds or electrovalent compounds, they have a high melting and boiling points. Whereas covalent compounds have a low melting and boiling points because the intermolecular forces of attraction, the van der Waals forces, are quite weak. Next, conduction of heat. Ionic compounds are good conductors of heat and also electricity because they have ions. But they will conduct electricity only in the molten or aqueous state because only then they have free ions. Covalent compounds are bad conductors of heat. Now they may conduct electricity if they are polar covalent compounds and they are dissolved in water. For example, HCl dissolved in water will conduct electricity. But non-polar covalent compounds like carbon tetrachloride, methane, even if they are dissolved in some solution, they won't conduct electricity because they don't have any free ions. Next, solubility. Like dissolves like. So ionic compounds are soluble in polar solvents like water because water also has charge separation. Non-polar covalent compounds are insoluble in water, but they are soluble in other non-polar solvents like benzene, whereas ionic compounds are not soluble in covalent compounds like benzene. Next, dissociation versus ionization. Dissociation happens in ionic compounds, in which the ions which were already present are simply separated because of melting or passage of electricity or dissolving in water. Ionization happens in polar covalent compounds like HCl, but this happens only when they are dissolved in water or when electricity is passed through it in the fused state. Here, ions were not present, but ions were created by breaking the covalent bond. So chapter 2, chemical bonding from the textbook. Introduction is not in syllabus, although you may read it if you want to revise the basic concepts of what an atom is and what are the component particles in an atom. Here we have the definition of a chemical bond. It's a linkage of force which acts between 2 or more atoms. Electronic configurations of noble gases are given. Notice that their last shell is complete following the octet rule and helium is following the duplet rule. That's why they are stable. They don't lose or gain or share electrons. They don't react. They are inert. All other elements would want to attain the stable electronic configuration of the nearest noble gas. That's why they react. That is the cause of reaction. So reasons for chemical bonding is tendency to attain stable electronic configuration of the nearest noble gas. This is the duplet and octet rule. Now there are 2 ways to achieve chemical bonding, either by electron transfer, which will form ionic bond, or electron sharing, because sharing is covalent bond. When is an ionic compound formed or an ionic bond created? Well, it's definitely between a metal and a non-metal, so that the electronegativity difference should be quite large. For example, sodium has low En, it's electropositive by the way, and chlorine has high En. So sodium will give away the electron to chlorine, sodium will become a cation, chlorine will become an ion, and an ionic bond is formed between them. IP of the metal should be quite low so that it can form cation. Ea of the non-metal should be quite high so that it can easily form an ion. What about covalent compounds? Well, For both the elements, IP, EA and EN should be high. That means both of them should be nonmetals. Covalent compounds are formed between nonmetals and even between a metalloid and a nonmetal. Now here, make this change, cancel between and write for, and cancel all elements. Notice that the electronegativity difference should be quite negligible between the two atoms, because if it's quite significant, then it would lead to polar covalent bond. Here we have the definition of ionic bond, ionic compound, and electrovalency. Differentiate between atoms and ions. Well, atoms are neutral, ions are charged. Atoms may or may not exist independently. For example, oxygen atoms don't exist in air. Oxygen molecules, that is O2, exist. But neon atoms can exist independently. Metal atoms, carbon atom can exist independently. So the molecule is monoatomic. Ions do exist independently, but only in solution. For example, chloride ion, Cl1-. It is present in a solution. It is not found in air. Atoms may or may not have an outermost shell complete, but ions will have the outermost shell complete. That's the whole point, they became ions. Oxidation is losing electrons and reduction is gaining electrons. And we have seen examples to understand whether it is oxidation or reduction. Here, in all these equations, you can see that they are gaining electrons. So that's reduction. Here, Fe's valency is 2+, because Cl is 1-, so crisscross, it will be 2+. Here, Fe's valency is 3+, because Cl3. So from Fe2+, it became Fe3+. That means it has lost electrons. That's called oxidation. And chlorine has undergone reduction. That's a redox reaction. So FeCl2 is a reducing agent and Cl2 is an oxidizing agent. You see, the substance which undergoes oxidation is called the reducing agent, and the substance which undergoes reduction is called oxidizing agent. And remember, nonmetals are usually the oxidizing agents and metals are reducing agents. Now let's understand the formation of sodium chloride. Sodium electronic configuration, chlorine electronic configuration, they want to attain the complete and stable valence electron configuration, just like the nearest noble gas. So sodium gives away 1 electron, chlorine takes 1 electron, they become ions, and there is an electrostatic force of attraction between them, due to which NaCl is formed. Now I always prefer showing the metal's electron with a cross so that I can differentiate between the original electrons of chlorine and the borrowed electron of chlorine. So brackets are important. This is called cross and dot structure. If they ask for formation, show the whole equation. If they only ask the final product, then just show this final product, and this plus sign is not necessary. If they ask for ionic equations, then these are the ionic equations: half oxidation, half reduction, and this is the total reaction. The reference, that is the orbital diagrams, are cancelled for all of these. Same way we can study calcium oxide formation. Calcium donates 2 electrons to oxygen, so oxygen becomes oxide and it's called calcium oxide. Calcium's name doesn't change, but oxygen's name changes to oxide. That's the rule of society. Notice that we have to write 2+ and 2- so that there is attraction between them, and write them close to each other, but don't forget the brackets. Ionic equations: metal is undergoing oxidation, non-metal is undergoing reduction. Diagram is cancelled. Even here, magnesium chloride, the diagram is cancelled. Here, magnesium is donating 1 electron to each of the chloride ions. So instead of writing the chloride ion twice, we can even write 2 out here. That's okay. Both methods are fine. So we have MgCl2, yet another salt, magnesium chloride. And these are the ionic equations. Notice that we have to write 2Cl. It should be a balanced equation. Next, covalent compounds. Well, these are the definitions. Covalency, for example, the covalency of oxygen is 2. When we write covalency, we don't write the charge. In electrovalency, there is a charge. But covalent compounds are again of 2 types. Non-polar, in which the shared pair of electrons are equally distributed. Both have almost same electronegativity, so both are equally greedy. So there is no charge separation. But what if there is some electronegativity difference? Then the shared pair of electron will be closer to the more electronegative atom. In this case, it is chlorine. So it acquires a slight negative charge, and hydrogen acquires a slight positive charge. Notice that it is not exactly like NaCl. In NaCl, there is a complete transfer because there was a huge electronegativity difference. But here, a polar covalent bond is formed, which is a kind of a hybrid between an ionic bond and a non-polar covalent bond, because they are sharing electrons, so it's covalent, but the shared electrons are unequally distributed. So there is charge separation, positive pole and negative pole is formed. So it's polar covalent compound formed. And such polar covalent compounds do show properties similar to ionic compounds, like they do dissolve in water. Non-polar covalent compounds don't dissolve in water because like dissolves like, and water is a polar covalent compound. So it will dissolve only other polar covalent compounds, that is these acids and even ammonia. Next, let's see the structure of hydrogen. So these are all non-polar covalent compounds. They are sharing a pair of electrons. Since both the atoms are same, H and H, I'm not using any cross. If it was a different element, then I would have used cross for one of the elements. They're sharing one pair of electrons with a single covalent bond. Diagrams are cancelled as mentioned earlier. Chlorine also share one pair of electrons so that both of them think that they have an octet complete. They don't actually think, but you get it. Oxygen's electronic configuration is 2,6. It needs 2 electrons to achieve the stable electronic configuration of the nearest noble gas, which is neon, 2,8. So to do that, if it does not have any metal nearby to donate its 2 electrons, then it would rather share with another oxygen atom. So they are sharing 2 pairs of electrons with each other so that both will have their octet. And this is called a double covalent bond. In case of nitrogen, it's a triple covalent bond because 3 pairs of electrons are being shared so that each nitrogen can have its octet complete and they will become stable nitrogen molecules. All these gases were diatomic. Now let's go for carbon tetrachloride. Here we know that carbon has 4 valence electrons shown by 4 crosses. Carbon will share an electron with each of the 4 chlorine atoms to form 4 single covalent bonds. That is how you write it in English. Frame it properly. So we have 4 single covalent bonds in carbon tetrachloride. Again, it's non-polar. Methane is similar to this. Again, 4 single covalent bonds. You can't call it a quadruple bond because it's not between the same 2 atoms. It's between different atoms. So carbon is sharing an electron with each, or a pair of electron with each of the 4 hydrogen atoms. So read the sentence here. So if they ask you to show the formation, write the whole equation. If they ask you to just show the cross and dot structure of methane, then only draw this much. If they ask you to explain how it is formed, then the theory is this table and this sentence. Diagram is cancelled, this one. Now let's study 2 polar covalent compounds. One is water. As already explained, in water we have 2 single covalent bonds. It's not a double covalent bond, it's 2 single covalent bonds. 1 pair of electron each with each of the hydrogen atoms. So we have 2 OH bonds. And in ammonia we have 3 single covalent bonds. Nitrogen is sharing a pair of electrons with each of the 3 hydrogen atoms. Notice that there is a pair of electron in the valence shell not participating in bond formation. That is called a lone pair. In water, there are 2 lone pairs that oxygen has, which has some significance. What would happen is, when we add an acid in water, for example HCl, water, it's a great divorcer, breaks the bond between H and Cl. So we get hydrogen ion and chloride ion, which is not shown here. Now, this hydrogen ion is nothing but a proton. And it's very important to mention it's from an acid. It could be any acid, sulfuric acid, nitric acid, hydrochloric acid. All acids dissolve in water to give hydrogen ion. That's the property of acid. Here's the definition of lone pair of electrons, by the way. So now water feels guilty because of it. He became lonely. So water will give it shelter. This hydrogen ion will stick to the water molecule. Notice that oxygen had 2 lone pairs to spare. So the hydrogen can easily get attached here. This is not disturbing the octet of the oxygen. It remains as it is. But at least now hydrogen can think that it has its duplet. But because hydrogen was positively charged, now the entire unit will become positively charged. That is called hydronium ion. And this bond, where a pair of electrons are being shared, but both the electrons are coming from a single atom. Usually in a covalent bond, each atom donates 1 electron in the pair shared. They contribute 1 electron. But here both the electrons are being contributed by oxygen alone. Hydrogen here is just for a free ride.
So it's called a coordinate bond, and we show it with an arrow like this. Notice one lone pair is still left, but no, it is not so generous that it will allow somebody else to get attached here. So this is hydronium ion, and this is the identity of an acid. Hydrogen ions cannot exist in water alone. They will always stick to water to give hydronium ions. And this is why litmus paper turns red and other acidic properties are seen. Now this part, hydroxyl ion, is cancelled. Even this is cancelled entirely. Now let's see how ammonium ion is formed. So when you dissolve ammonia in water, this time water will not be able to break the bond of ammonia. Instead, the reverse will happen. Water will break down. The divorce lawyer himself got divorced. So H and OH will split. So this time the hydrogen ion isn't from acid, it is from the water molecule. So we have to mention that. It's compulsory. And now again the same logic, ammonia feels guilty, poor hydrogen is alone. It does have a lone pair of electrons. So hydrogen comes and sticks out there. It doesn't affect the nitrogen's octet, but it at least satisfies this new hydrogen's duplet. But overall the entire unit becomes positive ion, and this is called ammonium ion, NH41+. And this is a coordinate bond. So this hydrogen ion came from water because H2O broke into H plus and OH minus. So the OH minus is also existing in water, but we need not show all this in this equation because it should be balanced. LHS and RHS should be shown. Since I did not show it in the LHS, let's cancel it from the RHS. Alternatively, you can show OH minus in both LHS and RHS. I prefer cancelling it because our focus right now is just to show the formation of ammonium ion, due to which ammonia is a basic gas. So this is a definition of a coordinate bond. It is also called dative bond or co-ionic bond. And if they ask for an example of a compound which has all three types of bonds, ionic, covalent and coordinate, then ammonium chloride is the best answer, because here I see covalent bond, I see a coordinate bond, and then there is an ionic bond. Cancel the other examples. Now let's differentiate between ionic compounds and covalent compounds, and also mark various give reasons or GRs. First of all, the state ionic compounds have very strong inter-ionic force of attraction, so they are all solids, hard solids like salt. Covalent compounds, they have weak intermolecular forces of attraction, which are also called van der Waals forces, so they exist as liquids and gases or soft solids. Well, if the density is less, then gaseous, and if the density is more, then liquid or soft solids. Cancel the word molecules and write density. Please understand that I'm talking about intermolecular forces, not intramolecular forces. For example, this is one molecule of carbon tetrachloride. Imagine that this was another molecule of carbon tetrachloride. So the attraction between them is van der Waals forces, which is quite weak. That is why carbon tetrachloride is liquid. But if I talk about intramolecular, there is a bond inside it. These 4 single covalent bonds, they are very strong, they are not weak. That is why we cannot break them easily. Next, volatility. Well, ionic compounds are volatile because they have non-volatile because they have strong interionic forces of attraction, and these are volatile, that means they evaporate easily because they have weak intermolecular forces of attraction. Same reason is for they having high melting and boiling point and they having low melting and boiling point, so mark that as a GR. Next, ionic compounds are good conductors of heat. These are bad or non-conductors of heat. Ionic compounds are good conductors of electricity, but not in solid state, only in molten state or aqueous state. You see, when you dissolve NaCl in water, ions are formed, Na plus and Cl minus. Or even if you melt NaCl, and when I say melt, it means without water, still ions are formed, Na plus and Cl minus. And because of the ions, it will conduct electricity. It's called an electrolyte. But in solid state, there are no free ions, so it will not conduct electricity. Covalent compounds are poor conductors of electricity because they don't have ions, but there is an exception to that. Polar covalent compounds like HCl, ammonia, they do have a charge separation, if you remember. So when you dissolve it in water, they will ionize. Cancel the word dissociate. Dissociate is used for ionic compounds, not for polar covalent compounds. When polar covalent compounds form ions like H plus and Cl minus, it is called ionization. And that is why then they can conduct electricity only in aqueous solution. So add that sentence and mark this entire thing as a GR. So non-polar covalent compounds cannot, and they don't even dissolve in water. But polar covalent compounds do dissolve in water and they will conduct electricity, but only in aqueous solution, not in liquid state. If you give me liquid HCl, and by liquid I mean without water, it does not have ions, so it will not conduct electricity. In fact, it won't even turn the litmus paper red. Sixth point, electrolysis is cancelled. Solubility, remember, like dissolves like. So ionic compounds will be soluble in water, but not in organic solvents, because water itself is polar. It has charge separation. On the other hand, non-polar covalent compounds will not dissolve in water. They will dissolve only in non-polar solvents like benzene, alcohol, etc. Reactions cancelled. Ionization and dissociation. I told you the difference here. NaCl is an ionic compound. That means it already had the ions which were stuck to each other. So if I melt it or dissolve it, I will get the ions separated. This is called dissociation. HCl is a polar covalent compound. There were no ions. There was only partial charge separation. So if I dissolve it in water, then they will break the bond and create new ions, H plus and Cl minus. That is called ionization. And it's reversible. Make that sign.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.